Waalaikumsalam. Madam.
All right. Okay. I think I'm going to start now. Okay. I think that some of you will be joining later. Okay. But first of all, before I start, just I would like to remind you regarding your assignment 3. Okay, it's due this Friday. So just make sure that everybody submit on time. Okay, before the due date. All right, and I just want to remind you again that I would like I do not want to receive any double entry this time for assignment 3 because previously people actually they already submitted to their group rep, but they also uploaded individually into the ULearn. Okay, so that will slow down my process of actually downloading and marking as well because then when I download all and then when I receive that the assignment only is individual assignment, then I have to actually check like one by one, okay, whether you belong to any group or not. Okay, so that actually will slow me down. Okay, so perhaps this time, okay, you just submit to once you submit to your group rep and that's it. You just need to trust your group rep that he or she will actually compile all the group members assignment, okay, group members individual assignment, and then the group rep will submit as like one PDF file, okay, and submit it into the ULearn. Okay, so you guys do not have to actually submit individually. Do not actually upload, okay, your own individual assignment into the ULearn. Okay, so I think this time if I receive, I will straight away delete. Okay, so I'm not going to check. Okay, all right. So that is regarding assignment 3. Okay, assignment 2, I've already finished marking, and I'm going to key in marks perhaps by tomorrow or maybe during the weekend. So hopefully by this weekend also you can actually check your 50% coursework marks. Okay. All right, and again, just to remind you again regarding the tutorial, okay, tutorial questions for this week. All right, just make sure that you all are keeping up with all the questions, okay, for chapter 4 as well as chapter 5 as well. You can actually start doing some of the tutorial question for vectors. And I believe that for this Thursday tutorial also, I think the afternoon session also will be joining the morning session, right? Okay, as mentioned I think last week. Okay. Uh, okay. What do you mean that coursework will only open till week 13? Oh, for checking marks. I'm not so sure whether it opens until. So that means now also you cannot check. This week is already this week 14. Oh, so you cannot check. Oh, it already closed. Oh, okay. I'm not so sure about that. All right. Okay. Okay, all right. If that's the case, then perhaps yeah, maybe it open until week 13. Okay, I don't know about this. Huh? But let me just check. Okay, let me just check perhaps with the admin office. Huh? Then I will just update you on this. Okay. Let's start now. Let me just share the content. Anybody got any question to ask before I begin? Okay. This is what we have. Okay. Just let me just recap. Okay, a bit of what we have done last week. Okay, we started with the vectors. All right, and actually we started with looking at what we call the three-dimensional coordinate system. So we showed you how to plot, okay, your point into the three-dimensional coordinate system. Okay, plotting point. Okay, and then you have your formula distance from 2 points, okay, in three-dimensional coordinate system. And then we move on talking about vectors, okay, and we introduce you with some terminologies, okay, on vectors, all right, in which we said that vector, you have what we call the initial point and terminal point, as well as vectors also we have direction as well as magnitude, okay, and some representation of vectors, okay, in terms of the letter, the bold letters, okay, that one, okay, those are just a notation, okay, notation for vectors. Okay, and then you have some terminologies on vectors like equality of vectors, zero vectors, all right. And then we talk about also arithmetic operation on vectors like addition and subtractions, as well as scalar multiplication, okay, scalar multiplication on vectors, all right. And then we also talk about components of vectors. Okay, for components of vectors, basically it is for both two-dimensional as well as three-dimensional, okay, vectors. And in terms of components, okay, you have certain notation, all right, you have certain representation, all right, whether you are using this type of bracket, okay, this type of bracket, or you can just use in terms of what we call using the unit vector, okay, a unit vector as a vector representation. And this type of IJK also, it has actually a name which is what they call the standard basis, okay. Standard basis is actually is what they call using the IJK, okay, something like this type, okay. This is what we call the standard basis of vector, okay, vector representation. So in terms of vector representation, okay, you have these two types, okay, and IJK, we mentioned about a unit vector in the direction of positive x, y, and z axis. So we will talk about this unit vector again, all right, later on. And we also talk about how do we actually plot vector, all right, in three-dimensional space. So basically, my emphasis actually is on the three-dimensional, okay. So whatever I draw, or even like doing arithmetic operation, all right, etc., I'll be actually emphasizing more on a three-dimensional space, okay. But for two-dimensional also is similar, okay, similar concept and similar process. Okay, so we have this is how we actually last week plot our vector. All right, so this is what we call just now the standard basis, okay, in terms of the IJK. All right, and then we have rules of vector arithmetic, okay. So all this you can actually look at, you can go through from textbook, okay, everything is in the book. All right, we have also theorems in which talking about how do we do arithmetic operation using components of vectors, okay, using components. So basically for this course, when it comes to arithmetic operations on vector, basically we are not using a diagram to draw, all right, but we are using components to do the arithmetic operation. Okay, and then we had examples also last week. Okay, how do we add, all right, or subtract vectors as well as scalar multiplication, all right, scalar multiplication. And then we also talk about the difference between the two types of vector where we call it like position. That's the one name which is position vector, and another one is actually where the initial is not at the origin. Basically, position vector is a vector where the initial is actually at the origin. Okay, so that is the position vector. And you have another type of a vector where initial is not at the origin. And we have seen that from this theorem, it is actually in how you actually establish in terms of components, okay, of vector, all right, from 2 points, all right, in space, all right, in this case it's in three-dimensional space, you have 2 points. So how do you actually find the vector, all right, in three-dimensional space from 2 points? Okay, so in terms of components of that vector, basically it will always be like terminal point minus initial point. So this one is very important, okay, because if you wrongly establish your vector component from a given 2 points, then perhaps this one will be actually wrong, okay. All right, and then we also have we had examples also last week, okay, to find vectors. All right, and then okay, I think this is where we stop. Okay, we stop at here. Okay, we stop at vectors here, and then I think today we are going to just continue with magnitude, computing or calculate magnitude of a vector. Okay, all right. So again, what we had previously was like finding vector. Okay, finding vector in terms of the direction. Okay, so when we had this type of example, let's say you are to find vector AB. Okay, vector AB with this arrow. So you are actually finding a vector in terms of the direction. Okay, this is actually represent direction. This vector component is actually represent a direction. It means that, all right, it is understood that from the origin you go to negative x-axis 4 units, and then you go to the positive y-axis, okay, 4 unit, and then you go to the negative z-axis 3 units. So basically what you have is actually is direction. Okay, so this vector basically this type with an arrow, all right, gives you direction. Okay, direction of that particular vector. Okay, but we said that vector also beside direction you also have magnitude. So vector has a magnitude, so that means we can calculate the length for vectors. Okay, and to calculate the length of vector, or to calculate the magnitude of a vector, okay, so basically we have that theorem. Okay, that's the formula. And if you look at this formula, all right, this formula, all right, this formula is where you have this vector v, with this component. This is also three-dimensional. You have three components, v1, v2, v3. This is a vector in three-dimensional space. So if you want to find the magnitude, okay, of that vector, you have this square root of v1 squared plus v2 squared plus v3 squared. Okay, basically again, the notation for magnitude is actually is similar to the magnitude of when we learn about complex number, isn't it? Okay, complex number in polar form, we find r. Okay, r is actually is a square root of x square plus y square. So similar concept. Okay, basically that r is actually is the distance, right? Okay, if you recall, okay, in complex number, r is actually represent a distance from origin to point. Okay, to a point. So this one also similar concept. All right. When it comes to magnitude, it is actually is the length of a vector, is the length from basically from the initial point to the terminal point. So you can compute the length. All right, you can compute the length by the same actually formula. Okay, for any distance. Okay, in this case, it is a square root of v1 squared plus v2 squared plus v3 squared, in which v1, v2, v3, these are components for three-dimensional vectors. Okay, all right, so let's straight away look at the example. How do you actually compute, okay, compute the magnitude? Okay, so let's straight away look at the example. Okay, so find the magnitude of the following okay vectors. Okay, so number one, you are given this vector AB is 1, 6, minus 3. All right, so first is all right, you want to find the magnitude of the following vector. So the first one is given this vector AB is 1, 6, minus 3. That is the component, okay? All right, so that means to find a magnitude of AB, okay, so this is what you want. All right, so by the theorem just now, it will be the square root of, all right, sum of, all right, square of each components, 1 squared plus 6 squared plus minus 3 squared. Okay, so if you compute this correctly, you will get this is square root of 46. Okay, when you compute for magnitude, all right, you do not need to actually use decimal. That means don't change that square root 46 to decimal number. No need. Okay, you can just leave your answer like that. And also, if you don't simplify the radical, also is fine. Okay, it is still okay. It's acceptable. Okay, all right. Okay, let's look at another one. Okay, perhaps you are given this time is this vector A, all right, which is in the form of 2i plus j plus 8k. All right, so finding the magnitude of this vector, it is the same as square root of 2 squared plus 1 squared plus 8 squared. Okay, so if you compute this correctly, you can double check this. The answer would be square root of 69. Okay, and again, don't change to decimal. So leave it as this exact value. Even though question may not say like finding exact value. Normally for this type of magnitude, this question, you hardly see the word exact value in the question. Usually the word exact value will only appear when you are dealing with trigonometry. Okay, like in your chapter 2. Okay, chapter 2 especially. So there'll be a lot of, you will see questions, all right, when it comes to trigonometry, like in chapter 2, they will mention about like finding exact value. Okay, without using calculator, find exact value. Those are for chapter 3, chapter 2 for trigonometry. But the rest of the chapter, like chapter complex number, even vectors, okay, you will hardly see, in fact never, okay, there's the word exact value appear in the question. Okay, however, all right, if let's say you saw the it mentioned like exact value, okay, then only you make sure that your answer is in terms of exact value. Okay, other than that, you can still use decimal, but like this one, as I mentioned, no need to change, just leave it as it is. Okay, just leave it in terms of this square root, okay, for the magnitude. Okay, let's look at another example perhaps, okay, for the magnitude. Another example. Okay, find the length of AB, vector AB, all right, given that A is 210, okay, and B is 145. Okay, can you try this in 1 minute? Can you give me the answer for this question? Okay, can you all try this? Okay, anybody got the answer? What's your answer? Okay, anybody got the answer? Anyone? Okay, anyone?
59.
59? You got 59? Anybody else?
Yes.
Okay. Anybody else? Any other answer? Okay, Shahmi, is it just now?
Yes. Yes, I do.
All right, okay. Okay. First of all, you got to find vector
Madam,
first, right? Yes.
cert 20.
Okay,
Is it?
another answer is set 20. Okay, just now 59. Okay, let's look at the answer now. Okay, first of all, this is finding the length of vector AB. So you are given 2 points, A and B. So first of all, you got to find vector. So this is what you need to find first. Okay, vector AB from 2 points. Okay, so again, it's understood when you are given a vector AB like this is the initial point. Okay, this is the terminal point. So when you establish the component, make sure it is terminal minus initial. Okay, I'm using that type of representation. All right, so then 1, okay. For x component, 1 minus 2. For y component, 4 minus 1. And then for z component, 5 minus 0. So that's how we establish our component vector, okay, for this vector AB. Okay, so 1 minus 2, so minus 1, and then 4 minus 1, so 3, and then 5 minus 0 is 5. So this is your vector AB. Okay, so then you want to find the length, so that means you want to find the magnitude. So it will be square root of, so 1 squared minus 1 squared plus 3 squared plus 5 squared. Okay, so that means this is square root of 1 plus 9 plus 25. Okay, then it is what? Square root of 35, isn't it? So that's the length. Okay, Shami and Adlina? Is it understood?
Yes, madam.
Okay, and the rest of you, I hope you can understand this. Okay, so this is how you compute for magnitude for this vector AB. All right, okay. Any question for this magnitude? Okay, then only then we move on. Okay. Question, Gloria? Yeah.
Can I see the previous example, madam?
Yeah, this one?
No,
Or the
yeah,
this one? Okay,
I want to screenshot for a moment.
okay,
Okay, done. Thank you, madam.
okay, welcome. All right, so then we come to again a unit vector. All right, so again, the word is unit vector as we mentioned previously. Okay, when you see the word unit vector, okay, when you see the word or when you come across the word unit vector, all right, straight away in your mind you must be able to understand that a unit vector means a vector of length 1 unit. Okay, a vector of length 1 unit. Okay, that means that the distance, okay, the distance, all right, the distance from the distance for that particular vector, okay, the distance, the length of that particular vector is 1 unit distance. Okay, which means that when you compute that particular magnitude equals 1. So this is what we mean by a unit vector. Okay, so that's why we can actually refer a unit vector on our axis like the ijk. Ij for the 2-dimensional, ijk is for the 3-dimensional. Okay, so when it comes to another type of vector representation, they use the ijk, all right, representation, because ijk is actually is a unit vector. Okay, it's a unit vector. Like for the ijk, it's a unit vector in the direction of positive x-axis, positive y-axis, and positive z-axis. Okay, so that is also another vector representation using the unit vector. Okay, but again, when you talk about unit vector, it means that the length of that particular vector equals 1. Okay, and most of the time, question may actually ask you to find, okay, find a unit vector in the direction of another given vector. Okay, another given vector. So normally the question would actually ask you for that. Okay, and before we look at that particular question, another thing that it is actually is another thing that you must always understand when we talk about again a unit vector, to get a unit vector, all right, the process is actually is using what we call normalizing. Okay, normalizing, the word is actually normalized vector, normalizing. Normalizing means vector divide by its magnitude. Okay, vector divide by its magnitude, that is what we call normalizing. Okay, normalizing. So when we want to find a unit vector in a direction of a given vector, okay, for example, like this one, okay, if you look at this this statement, okay, the statement here, all right, okay, normalizing a vector is actually is a process of obtaining a unit vector. In this case, they represent a unit vector in this representation U. Okay, U is actually is a unit vector. So normalizing a vector is the process of obtaining a unit vector U that has the same direction as some given non-zero vector v, that is, okay, u equals to v divided by its magnitude. So this actually gives us a unit vector with the same direction as v, and the length is 1. Okay, so what it means? It means that, okay, it means that if let's say, all right, if let's say you are given, okay, you are given one vector, you are given a vector. In this case, you are given a vector v, okay, and you want to find a unit vector in the same direction, as vector v. Okay, so vector v is given. Okay, this vector v is given. You are given a vector v, and you want to find a unit vector. Okay, so again the word is unit vector. So unit vector means that particular vector will have length equal 1. So you want to find a unit vector in the same direction as this vector v. Okay, so what you need to do, the word is actually is normalizing. The process is what we call the normalizing. All right, normalizing vector v. We need to normalize this vector v. In order for us to find a unit vector in the same direction as vector v, we need to normalize. Okay, so we need to normalize vector v, that is, normalizing means take that vector v, divide by its magnitude. Okay, this is actually is process of normalizing. Okay, normalizing vector v, and this process will give us, all right, will give us a unit vector, all right, in the same direction as vector v. This is what it means. Okay, so this is what it means. So you are given a vector v, you'll be given a vector. In the first place, you are given a vector. In this case, is vector v. All right, and then question may ask you to find a unit vector in the same direction as this vector v. So in order for us to find that unit vector in the same direction as vector v, what we need to do is we need to normalize that vector v. So how do we do that? By taking that vector v, we divide by its own magnitude. So the whole thing, all right, the whole thing will give us a vector. Okay, the whole thing will gives us a vector. All right, and this process is what we call normalizing, and this process of normalizing will give us a unit vector in the same direction as vector v. All right, and the length of the whole thing here, because this is actually is a unit vector. When it is a unit vector, all right, when it is a unit vector, that means if you compute the magnitude of that vector, that unit vector, okay, all right, you compute the magnitude of that unit vector, you will see you must get answer is equals to 1, because it's a 1 unit. That's why it is called a unit vector. Okay, so this is what it means. Okay, so that means the inside one here, this is a unit vector. That is a unit vector. So if you take the modulus, okay, of that unit vector, which means you must see that you get this equals to 1. So this is what it means. Okay, all right, so let me just give you an example so that it makes sense to you. Okay, let's look at a few examples. Okay, so given vector u, which has this direction, 4i plus 3j plus 2k find a unit vector in the same direction as vector u. Okay, so given vector u, all right, which is 4i plus 3j plus 2k, find a unit vector in the same direction as vector u. Okay, so again, the keyword here is actually finding a unit vector, all right, as well as another word which is same direction. That is another keyword, okay, for this question that you have to look for. So you are to find a unit vector in the same direction as vector u. So vector u is given as 4i plus 3j plus 2k. So earlier we said, how do we find a unit vector? We need to, the process is normalizing. Okay? The process is actually, or the method is actually is what we call normalizing. Normalizing means you take that given vector, you divide by its magnitude. So this is what it means, normalizing. So unit vector, to find unit vector, you need to normalize. Normalize what? Normalize the vector that is given here, because you want it to be the same direction as the given vector u. So you normalize this vector u. Okay, so from the process, you know that you need the magnitude. All right, so then straight away perhaps compute the magnitude. Okay, compute the magnitude for this vector u. Okay, so compute magnitude. So straight away, square root of 4 squared plus 3 squared plus 2 squared. Okay, so you can compute this. You can check this. You will get this is actually equals to square root of 29. Okay, all right, so therefore, what you want is actually a unit vector which is in the same direction as vector u, right? Is, so again from the earlier, all right, explanation, you just take that vector u, divide by, all right, its magnitude. So which means, all right, which means vector u is 4i plus 3j plus 2k, 4i plus 3j plus 2k divided by square root of 29. Okay, but don't leave your answer like this. Okay, because final answer you must write in the form of vector, all right, vector component, which means either in the form of the bracket, okay, or you are using the IJK, but don't leave it as like this. So you just need to simplify. That means, okay, you can write it in terms of like this, 4 over sec 29i plus 3 over sec 29j plus 2 over sec 29k. You can write like this. So this is a unit vector. Okay, this is the unit vector. This is actually is your answer. Or, all right, or if you can also write in this type of representation, the bracket representation also can. So either one. Okay, so either one. So that is actually, all right, this is actually is a unit vector which is in the same direction as vector u. Okay, either you say this one or this one. Okay, so 4 over sec 29i plus 3 over sec 29j plus 2 over sec 29k. This is actually is a unit vector which is in the same direction of vector u. Okay, if you want to just verify, okay, I just want to show you, all right, because earlier we said this, all right, because we said that it is a unit vector. So how do we know that it is a correct unit vector? You can always check the magnitude if you want, okay? So you can check the magnitude here. If you check the magnitude, you compute the magnitude, you should get equals 1, all right? You should get equals 1. It's a must because it's a unit vector. So if you want to see, all right, or if you want to check whether this answer is correct or not, all right, that means if you want to check or to verify, maybe I can show you, all right, how do we verify this? All right, that means what you need to do, you need to actually compute, all right, the magnitude of just now, that vector, uh, u just now, the unit vector, this one, and see whether equals 1 or not. Okay, this is what you need to see. Okay, which means that you are going to compute the magnitude of this one just now, 4 over cert 29, 3 over cert 29, 2 over cert 29. You want to compute the magnitude of that unit vector. Okay, so let's compute this. Let's compute this. All right, let's compute this magnitude of this unit vector, which means 1 big square root. All right, 1 big square root. So to compute the magnitude, it will be 4 over 29, the whole thing squared, plus 3 over 29, the whole thing squared, plus the whole thing, all right, 2 over 29, the whole thing squared. So you compute this, all right? Okay, which means we have 4 squared, 16 over square root and square. So square root disappear. So you have that 29. Okay, so then 3 squared is 9 over 29. And then you have 4 over 29. So 16 plus 9, 25. 25 plus 4, 29. So you have 29 over 29. That means it's square root of 1, which is 1. Okay, so it's verified. All right, that the magnitude of that unit vector must equal to 1. Okay, so this is what it means, a unit vector. That the magnitude, if you compute the magnitude, you compute the magnitude of the unit vector, you compute the magnitude of unit vector, it is actually equals to 1 unit. Okay, 1 unit length. Is it understood? Is it understood? Any question? Okay, I have another example. Similar but different. Okay, what does it mean? Similar but different. Okay, let's look at this. The next one. Okay, find a unit vector in the opposite direction of vector W, which is equals to 1 minus 2, 3. Okay, so this time, find a unit vector in the opposite direction of W, all right, vector W, and this vector W has this vector 1 minus 2, 3. Okay, so again, what's the keyword here? It's again unit vector that you want to find, all right. Another keyword, opposite direction. Okay, opposite direction. Just now, the previous example, same direction. This time, opposite direction. So what does it mean? Opposite direction. Opposite direction of a vector. If you have one vector, remember, if you have a vector u, for example, okay, if you have a vector, if you have, let's say, assuming this is vector u, So if you have this vector u, for example, what does it mean by opposite direction? So you have another vector goes opposite direction. Let's say this is vector A going opposite direction to vector u, like that, right? Okay. And if they have a same length, that means you can say that if, let's say, magnitude is the same, you can say that it has something like this, isn't it? Or vice versa. You can say like that. Okay. All right. You can say like this. So vice versa. Okay. That is what it means by opposite direction. So that means the word opposite means negative sign. Okay. Opposite direction, all right, tells us in terms of the negative sign. All right. Which means that, back to our understanding just now, to find a unit vector, you got to normalize. Okay, when you want to find a unit vector, meaning you have to normalize. Normalize means you take the given vector, divide by its magnitude. Okay, so that means you know that a unit vector in this case is W. So you want to find a unit vector, okay, in the direction of W, you know you are going to normalize. Normalize means you take that vector W, divide by its magnitude. But because there's a word opposite direction, then you must not forget to put a negative sign. You must put negative sign. So this negative sign tells you opposite direction. Opposite direction. If it is same direction, you don't have any other sign. So if you don't have any other sign, that means it's understood is positive sign. Positive. Okay, if there's nothing written, all right, in front of that, that means the sign is positive. So you don't write. Okay, but when it is opposite direction, you must put your negative sign. Okay, you must put your negative sign. Okay, so this negative sign tells you in terms of opposite direction. All right, okay, so then let's compute straight away the magnitude, because you need the magnitude of this vector W. Okay, so which means that it is square root of 1 squared plus minus 2 squared plus 3 squared. All right, so that is square root of 14. Okay, so that is square root of 14. All right, then therefore a unit vector, all right, a unit vector in the opposite direction of W is, okay, all right, so W divided by its magnitude, but don't forget there's a negative in front. Okay, so don't forget there's a negative in front. Okay, which means, all right, so negative. All right, then vector W is 1 minus 2, 3, divide by square root of 14. Okay, which means that you multiply that negative, all right, multiply that negative to each of the component. That means minus 1, positive 2, minus 3 over square root of 14. Or in other words, your answer, either you write in terms of this component, minus 1 over square root of 14 to square root of 14, and minus 3 over square root of 14. Again, or you can write in terms of IJK. Okay, you can write in terms of IJK. Okay, you can write like this. Okay, this is right. You can write in terms of IJK. All right. So again, either you write in terms of component, okay, in the bracket, or you write in terms of IJK. Okay. Can you see? Can you see the answer, the final answer? Can you all hear me?
Yes, madam, yes.
Yes, madam.
Okay. All right. Okay, you can actually verify if you want. All right, you can verify. All right, verifying is just optional. All right, but if you want to check whether your answer is correct or not, as I said, you can compute the magnitude. You can compute the magnitude of this. All right, you can compute the magnitude of this and see that. All right, when you compute this magnitude, it must equal 1. This is how you check, okay, or you verify, okay. But this is optional, okay. Unless the question asks you to do that, then you show. If not, you don't have to. But if you want to, it's up to you, okay. All right. I have another example. Any question for this question 2? Anybody got any question? Is it understood? Okay.
Yes, madam.
All right. Okay. Another example, or perhaps this is the last example for a unit vector example. Okay, this time you are given this vector A, which is 2i minus 6k, and another vector B has this direction, which is minus 4i plus j plus 5k. So you want to find a unit vector in the same direction as 2a plus 3b. Okay. All right. Okay. Given vector A is 2i minus 6k, and vector B is minus 4i plus j plus 5k. Find a unit vector in the same direction as 2a plus 3b. Okay. Again, you would see that there's a word unit vector again. And you would see that the word same direction also appear. So when it is same direction, you know that, okay, if it is a unit vector, the word unit vector means you need to normalize certain vector. Okay, you need to normalize. That means the moment you see find a unit vector, that means there will be a normalizing process of a certain vector. And then with the same direction word, same direction, meaning to say that when you normalize, it's a positive sign in front. Okay, it's not negative. If it's opposite, negative. It's same means positive. Okay, but what vector that you need to normalize is what vector? What vector that you want to normalize? It is this vector now. The vector is actually is in the form of 2a plus 3b. So it's a sum of of this vector A and B here. Okay, so that means the one that you want to normalize is this vector here, 2A plus 3B. That's why you are given these two vector A and B in the first place. Okay, because then you need to find this one first, find this 2A plus 3B, then only with this word you normalize. And because of this word same, you have a positive sign in front. Okay, so I hope you understand this. Okay, so let's do this. So that means firstly what you want is the sum. Find the sum of 2A plus 3B, which means 2 times A is 2. Okay, maybe I write in terms of this bracket component. That will be much faster and easier. Okay, but there's no J in this case for A, so that means J is 0. Okay, and then minus 6. Okay, and then plus 3 times B. B is minus 4, 1, 5. Okay, so which means that it is 4, 0, minus 12, plus with vector minus 12, 3, 15. Alright, so then the sum is, alright, minus 8, 3, minus 27. Any questions so far? So you got to find the sum of this vector 2A plus 3B first. Okay, so once you've got this vector 2A plus 3B, so this is now the vector that you want to normalize. You are going to normalize this vector because you want to find a unit vector in the same direction as this vector here. This vector minus 8, 3, minus 2, 27. And this is actually is from 2A plus 3B. Okay, so that means next step is quickly just compute for the magnitude. Magnitude of this 2A plus 3B. That means you need to find the magnitude of square root of minus 8 squared plus 3 squared plus
Madam,
plus minus 27. Yes?
I think you calculate
Yes.
wrongly. The minus 12 plus 15.
Which one?
Vector
Oh,
K.
minus,
K.
okay. Oh, okay, sorry, it's 3, isn't it?
Yes, madam.
Okay, minus 12. Okay, it's 3. Okay, thank you. All right. Okay, so then 3. Thank you. All right. Okay, so that means, all right. Okay, 3 squared. All right, okay, so then we compute. All right, so 8 squared, all right, plus 3 squared plus 3 squared. So we have our square root of 82. Okay, is that correct? Okay, I'll write down here. Okay, maybe I'll write just down here. I hope you can see this. Okay, so that is the magnitude. Okay, all right, so now you are ready to normalize. Okay, so we want a unit vector in the same direction as 2A plus 3B. So therefore, a unit vector in the same direction of 2A plus 3B is, okay, so that means it will be just now your 2A plus 3B divide. Okay, Hakim, do you have a question? All right. Okay, divide by its magnitude. Okay. Again, same direction means it's positive. All right, it's positive. Okay, so that means 2A plus 3B just now is your minus 833. Minus 833. divide by square root of 82. So then your final answer, you write it in terms of minus 8 over cert 82, 3 over cert 82, and 3 over cert 82. That's it. Just leave your answer like that. Okay. No need to change to IJK. Alright. But if you want to write in terms of IJK, also can. No problem. Okay. Any question? Can you all understand this? Is it understood? To find a unit vector in the same direction or in the opposite direction of a given vector?
Madam,
Yes?
I wrote it in terms of IJK from the start.
Can. Can.
Okay.
That means from the start from here. Or you mean
Yeah.
from the start from here?
From start.
Can.
Yeah, from up.
Can.
Right.
Can. Alright, you can use IJK or you can use this representation. It doesn't matter. Okay? It means the same thing. Alright? As long as your vector is the same. Okay? It's correct. So you can write, in fact, you can write interchangeably also. It is actually allowed. Interchangeably means, you know, suddenly this is IJK and then this using that. Okay, it's fine. It's not a problem. Okay, but of course, on your side, okay, perhaps it will be more easier. It is easier if you just consistent, isn't it? Be consistent. If you're using IJK, maybe IJK throughout. Maybe it's much easier on you. But on our side, if you interchange your IJK and then this type of bracket, it doesn't matter. Okay, we accept. Okay, as long as your answer is correct. Okay. Any other question before we take a break? It's already 3 o'clock. We can take a break for 5 minutes.
Madam, can you scroll up, madam?
Which one? This one? This question?
Yes, madam.
Or
Yes,
this?
yes.
Okay. Okay. You want me to scroll down?
Yes, madam.
Okay. So
Yes.
this is the continuation. I will actually, I will also upload this recorded session as well, alright, into the Ulearn. Okay, but
Okay, thank
I
you,
will
madam.
do that later. Okay, alright. You can check also, for last week one, I've already uploaded. I can do that only during weekends, not weekdays. Either weekends or on Friday. Alright, okay. Any other question before we take a break? If not, then okay, let's take a break for 5 minutes and then we'll continue. Okay, then we'll continue with another type of multiplication, vector multiplication, which is dot product. Okay, 5 minutes break. All right, okay, is everyone there? Okay, is everybody there? Anyone?
Yes, madam.
Yes,
Okay,
madam.
all right, okay.
Yes,
Okay,
madam.
all right, okay. I hope you can listen me. I cannot. Okay, somehow I'm actually my WebEx at my laptop. I think got something. There's some technical error. It's actually it doesn't move. It actually is frozen. Okay, so I cannot read any chat that you wrote. If you do the chatting, I cannot actually read. So if you have any question, you just let me know. All right, okay, let's continue. So this time is actually we are talking about dot product. Okay, so dot product basically is another type of or is a vector multiplication. Okay, so dot product is actually is a multiplication. It's a multiplication of two vectors. Okay, this is what we call dot product. Because why we call it dot product? Because the product is actually is a real number, or is a scalar number. It's a real number. Okay, it's a real number. The product is a real number or scalar number. Okay, so that's why it is also another name is actually they call it scalar product. Sometimes you may come across the word scalar product. Okay, scalar product, because the product is actually is a number. It's a number. It's not a vector, but it's actually is a number. Okay, so then for this scalar product or this dot product, basically in terms of notation, okay, in terms of notation, okay, let's say you have these two vector u and v, so we use like dot in the middle. Okay, so that's why it is called dot product, because the notation is actually is using a dot in the middle. So that's why it is called dot product. Okay. All right, and in terms of geometric illustration, so you have like the, assuming this is initial point, so you have this is one vector u here, and then the same on the same initial point you have another vector v here. So when you look at in terms of geometric illustration, there's you can see that there's an angle that is formed for this dot product. Okay, angle is actually formed, okay, by this type of product. And that's why later you will see that in terms of definition, okay, the definition for or from a theorem, it has actually something dealing with theta, with angle. Okay, all right, for dot product. Okay, but before that, let's look at in terms of component. Okay, how do we actually multiply? Okay, multiply these two vector using what we call dot product. Okay, there's a definition here. All right, so basically if let's say you have one vector u is given as u1 u2 u3, and another vector v, okay, has this component v1 v2 v3. All right, so to find the dot product, okay, if you look at this definition, you will see that in terms of the component, when we multiply using dot product, basically what we do is we multiply first component for both vectors plus with a product of, you know, second component of two vectors plus with a product of third component of this vector. Okay, these two vectors. So that's how we find the product or find the multiplication of these two vectors using what we call dot product, okay, or scalar product. Okay, all right, and again, the result or the output will be a number. It's not a vector, but it is actually is a number. Okay, let me just quickly give you an example. Let's say you have this vector, okay, 1 minus 2 minus 1 dot with another vector minus 6 2 minus 3. Okay, all right, so to find the product, okay, to find the product, what you need to do, all right, you just need to multiply the first component for each, plus you multiply the second component for each vector, both vectors, and then plus with a product, all right, of the third component. Okay, that's how we do the what we call dot product. So it means 1 times minus 6 plus minus 2 times 2 plus minus 1 times minus 3. Okay, so which means this is minus 6 minus 4 plus 3. Okay, so then you have your minus 7. Okay, so this is how we do dot product. Maybe I'll give you another example. Okay, let's say you are given in terms of ijk, half I plus 3j, and then plus k, and then you dot with 4i, and then minus j, and then plus 2k. All right. So you want to multiply using dot product. Okay, that means half times 4 plus 3 times minus 1 plus 1 times 2. So which means this is 2 minus 3 plus 2. So the answer is 1. So you will see the answer. Okay. All right. The answer. Okay. I think okay. I think someone actually forgot to mute. It's okay. Mute your mic. All right. Okay. All right. So you see the product is actually is a number. The product is actually is a number. Okay. So that's why it is actually called dot product, or they call it scalar product. Okay. Let me just give you perhaps another example. Okay, one example. Okay, let's say you are given a point. You are given 3 points in this case. PQR. P has a coordinate of 3 minus 2 minus 1, and then you are given Q is 1 5 4, and another one R is given as 2 0 minus 6, and then find PQ vector PQ dot vector PR. All right. Okay. Or can you try this? Can you try this example, this question quickly? All right. You're given 3 points, P, Q, and R. Find vector PQ dot vector PR. Okay, you got to find a vector PQ and PR first, and then only you can multiply using dot product. Can you try that quickly? Okay, anybody got answer? Okay, anyone? Or can someone tell me what is vector PQ?
Negative 12.
You got dot product negative 12. Okay, tell me what is vector PQ first. Okay, what is vector PQ? Anyone? Vector PQ?
Negative 2, 7, 5.
Okay, negative 2, 7, 5. What about PR?
Negative 5, 2, negative 5.
PR? Negative?
5, 2, negative 5.
Negative 5, or is it minus 1? PR.
Oh, sorry. Minus
Minus
1.
1.
Yeah, you are looking at P and R here. Eh? So it will be minus 1, isn't it?
Minus
Minus
1.
1.
Yes. Minus 2. Minus
2
5.
or 2? The middle is 2 or minus 2?
Minus 2.
2.
2.
So
2.
2. 0 minus 2.
Dua.
So So it's 2, 0 minus minus 2. So it's positive 2. Okay, then the last one is minus 5. Okay, so you make sure you got correct vector. So if you got wrong vectors, that's when your dot product will be wrong. So you have to be very careful. Okay, so then only when you dot PQ dot PR, that means, all right, minus 2 times minus 1 plus 7 times 2 plus 5 times minus 5. So that means you have your 2 plus 14 minus 25. So what is that? Minus 9, isn't it? Okay. All right. Any question? Okay, everybody?
Okay, madam.
Okay, then you have, all right, okay, good. Okay, then you have also properties in the book. You have several properties of dot product. Okay, this one you can actually read, all right, in your textbook. Okay, this is what I mentioned earlier. Okay, because geometrically you have your, this is vector u, this is vector v, so you have angle in the middle. So then by this theorem, you have actually this sort of like a definition, okay, which is dealing with angle. Okay, so you have cosine theta equals to a dot product u dot v divide by the magnitude of u and then multiply by magnitude of v. So this is actually is another important theorem, okay, that you might want to, well, you don't have to memorize, but it's good if you can actually remember this by heart. Okay, but actually you don't need to memorize, because using during final exam you can always refer, okay, that the formula from your textbook. Okay, so but this is actually is a theorem whereby it actually relates your dot product with angle. Okay, dot product with angle, as well as there's a magnitude here. So you have this theorem, okay, that the angle between this vector u and v is given by cosine theta equals to u dot v over magnitude of u times magnitude of v. So which means if there's a question asking you regarding angle, okay, question is asking you like find angle, okay, find angle, or maybe also they can ask you find dot product, but they give you angle and they give you vectors, two vectors. So you can actually use this type of definition to find the either dot product or to find angle, depending on what question wants. So perhaps we will actually look at the example later, but there is also another thing that we have to note, because when we are dealing with angle, okay, when we are dealing with this angle, and the definition is actually is cosine theta, all right, cosine of the angle. So perhaps we can actually observe, okay, we can observe certain things regarding the angle, all right. If you have, okay, actually, this diagram, there's the typo, all right. This is actually is not V, this is U, this is vector V here, all right. So you can observe certain things that when from this figure, what it says is that U dot V greater than 0 means positive. This means, all right, this means positive. Okay, positive. All right, so from this figure it says that, all right, if the dot product is positive, that means your angle is actually is acute angle, and it goes vice versa. If angle is acute angle, that means dot product is positive. This is what it means. Okay, all right. And another figure also tells us that, you know, this is also U and V typo. All right. It says that if your dot product is negative, okay, if dot product is negative, that means the angle here is actually is obtuse angle. Obtuse angle means angle more than 90 but less than 180. This is what I mean by obtuse angle. Okay, and it goes also vice versa. If your angle is obtuse angle, that means the dot product is negative. Okay, And the most important observation is this one. Okay, is this one. This is the most important observation, and from this observation, then there's a theorem that is actually deduced from this observation. All right, it's about a right angle. So when theta is 90 degrees, okay, when theta is 90 degrees or right angle, dot product is said to be equals to 0. Okay, all right, and also vice versa, you can also say that if the dot product equals 0, that means this angle here is 90 degrees, which means these vectors here, vector u and vector v, they are what we call the concept of what they call orthogonal vectors. Orthogonal or perpendicular. This is what it means. Okay, perpendicular or orthogonal vectors. So this is one important theorem. Okay, one important theorem. All right, which says that if two vectors are orthogonal, all right, if two vectors are orthogonal, that means their dot product equals 0. Okay, or vice versa, if dot product equals 0, that means those two vectors are said to be orthogonal or perpendicular. Perpendicular or orthogonal means theta equals 90 degrees. That means the angle between these two vectors is 90 degrees. This is what it means. So this is deduced to a very important concept. If u dot v equals 0, then u and v are orthogonal vectors. So you will have like certain questions which ask you to determine whether two vectors are perpendicular or determine whether vectors are orthogonal vectors. So if you want to check whether two vectors are orthogonal vectors, what you need to do, you need to find their dot product. And their dot product has to be 0. If dot product is not 0, that means those two vectors are not orthogonal. But if dot product equals 0, that means you know those two vectors, all right, those two vectors are orthogonal to each other. Okay? All right, so let's look at example. Okay, let's look at example here. Okay, so if you can see this example. All right, so in this example, vectors u and v are given in terms of the length. If the vectors u and v have lengths 4 and 6 respectively, and the angle between them is pi over 3, find u dot v. Okay, so from this question, you are given length of u and v accordingly, okay, respectively. That means from the question, length of u is given as 4 unit. Length of vector v is given 6 unit. And another thing that is given also from the question is the angle. Okay, maybe I represent that angle by theta. Okay, you can just use any other letters if you want. So theta is pi over 3 given. So either pi over 3 or you want to put at 60 degrees also acceptable. Okay, find u dot v. So earlier I mentioned if there's something with the angle given, that means it requires you to use this definition or this theorem, that cosine theta equals to u dot v over magnitude of u and magnitude of v. Okay, Loga, do you have a question? Okay, you raise your hand.
Madam, no, madam.
Okay, Loga, do you have a question?
No, madam, no, madam.
Oh, okay, all right, okay, all right. So using the theorem earlier, okay, the theorem which is about cosine theta equals u dot v over magnitude of u times magnitude of v. Okay, so using this theorem, so from the question, length u and v are given, theta is given. So what you want is actually is this. What is u dot v? So it's just a matter of rearranging, all right, the equation. And what you want is actually is u dot v. So when you rearrange, you can just write it as this. Okay, the length of u times length of v times cosine theta. So then you just substitute accordingly, okay, with all the information given. Then you just compute. Okay, cosine 60 degrees. Cosine 60 degrees is half, isn't it? So that means the answer is 12. Okay? Alright, question. Let's look at another example. Okay, let's look at another example. Find the angle. Find the angle between these two vectors, vectors A and B. Okay, so vector A is given as 2, 2 minus 1. B is 5 minus 3, 2. So again, you want to find angle. So that means you are using again the same theorem just now. But this time, you are given in terms of A and B. So you just change the letters only. Okay, but the theorem is still the same. That cosine theta is a dot product between A and B divided by the magnitude of vector A multiplied by the magnitude of vector B. So what you want is the angle. You want theta. So that means later, you just need to find cosine inverse of this. This is what you want. Okay, so to find angle. Alright, so then find your dot product, find your magnitude for each vector A and B. So find dot product, so that means find A dot B. So that means, can I just straight away compute this? So that means 2 times 5 plus 2 times minus 3 plus minus 1 times 2. Okay, so you have your 10 minus 6. All right, 4. So 4 minus 2, so 2. So that is your dot product. Okay, and then find the magnitude for each. Find magnitude of A. Okay, A just now is 2, 2 minus 1. So that means 2 squared plus 2 squared plus minus 1 squared. Okay, so 4 plus 4 plus 1. So then it's square root of 9, which is 3. Okay, then find magnitude of vector B, which is 5 squared. Alright, plus minus 3 squared plus 2 squared. Okay, so 25 plus 9 plus 4. Okay, so that is square root of 38. Okay, no need to change. Leave it as it is. Alright, then theta. Now you can substitute accordingly. Alright, from here, okay, based on this. Alright, that theta equals to cosine inverse A dot B over the magnitude of A times magnitude of B. So then cosine inverse of A dot B, so A dot B is 2 over, alright, 3 times square root of 38. Okay, use your calculator. Okay, I'll give you the answer in terms of the nearest degree. Okay, so you can try also. See whether you got the same as mine, which is this is 84 degrees. This is the to the nearest degree. You can use decimal. You can give us in terms of 1 decimal or 2 decimal. Doesn't matter, because as I said, it doesn't mention in the question, right, whether to give us answer in terms of nearest degree or in terms of 1 decimal or 2 decimal places. Okay, but during exam, you read the question carefully. Okay, if they ask you, okay, state the angle in the nearest degree. Okay, so then nearest degree, or if they say with 1 decimal places, 2 decimal, so you follow the question. So read the question carefully. All right. Okay. Any question? This one? Any question? Okay, this one understood? Okay, let's look at the next example. Okay, now this is an example where determine whether, okay, actually determine whether both vectors, not u and v, because you have part A is a and b, and then b also u and v, so not only u and v. Determine whether both vectors, okay, are orthogonal vectors. Okay, what you need to do is just to check their dot product. So the first part is between A dot B. So A dot B, 1 times 6 plus minus 2 times 3 plus minus 2 times 2. 0 or not? 6 minus 6, 0. But then you have your minus 4, isn't it? So minus 4. So not 0. So therefore, A and B are not orthogonal vectors. Okay? Okay, what about B? Okay, check U dot V this time. That means 3, okay, 3 times, okay, what is, if you look at V, is there any I? There's no I. Okay, so that means I is 0. Plus, okay, minus 2 for J, another J is 2. Plus, okay, 1K, so that means 1 times 4K, 4. So 0 minus 4 plus 4. Okay, so this, in this case, is 0. So that means U and V are orthogonal vectors. Okay. All right. Question? Understood? Okay. All right. Okay. There is also what we call, okay, the concept of direction angles. Direction angles, or sometimes you see the word direction cosine, they call it. Okay, direction angle or direction cosine is because based on the theorem earlier, where you have the theorem in which you have cosine theta equals to u dot v over magnitude, all right, of u times magnitude of v. So that means there is actually, of course, angle involved. Okay, when you look at direction vectors means, okay, or direction angles means you have a vector and then you look at angles that is formed between the vectors in this case. All right, for if you look at this this diagram here, this is for 3-dimensional. All right, direction angle means is a angle formed by this vector r. You have one vector, position vector r. Okay, and you have actually angle that is formed by this vector and this unit vector I, or x-axis in this case, right? X-axis. So this is actually is one angle here, which is actually represented by alpha, and then another angle which is formed by same vector with y-axis. So this one is actually denoted by beta. Okay, and then another angle which is formed by the same position vector with z-axis. Then in this case, they represent by gamma. So basically, you have all these alpha, beta, gamma are the angles. Okay, alpha, beta, gamma are the angles which is formed by this position vector r with positive x-axis, positive y-axis, and positive z-axis. Okay, so when we talk about direction angles, okay, for three-dimensional coordinate system, so you will have three angle alpha, beta, gamma. If you're talking about direction angles in two-dimensional, you only have two angles only. Okay, the one that is represented by that vector r with x-axis, and another one is that vector, all right, with y-axis. So basically, you have only two direction angles. Okay, and in terms of the theorem or some sort like a formula, how do we find direction angles? So if you look at this, you have this. All right, you have this formula here. All right, and if you observe the theorem, all right, the direction cosines of a non-zero vector v, which is v1i plus v2j plus v2k are, okay, cosine alpha equals, okay, because alpha is actually angle which is formed by the position vector v here with positive x-axis. So that means you are looking only x coordinate. V1 here, this is the x coordinate, but denominator is actually is the magnitude of the vector v. Okay, magnitude of vector v. All right, not v1. V1 is actually is a coordinate. Okay, component. V1 is component vector. This one is the length. Okay, so the length is actually is length of vector. Okay, up here is actually is just a component. Okay, component vector. This is x component. For beta is the y component, because beta is angle formed by vector v with y-axis. So this is y coordinate. This is z coordinate, okay, or the third component, all right, because the gamma is actually is the angle that is formed by vector v with z-axis, positive z. So then here is v3, okay, or the third component. But down here is all magnitude. So magnitude is must be magnitude of the vector v. So basically, if you have the cosine expression, cosine alpha, cosine beta, cosine gamma, this is where they call it direction cosine. When they say direction angles, means that they're asking you for alpha. They're asking you for beta, they're asking you for gamma. So basically, this is all cosine inverse. Okay, cosine inverse of whatever, all right, whatever this one is. Okay. All right, so perhaps let's look at examples so that it makes sense to you. All right. Find the direction cosine. Find the direction cosine of this vector v, which means, all right, this is your v1, v2, v3, okay? Or this is your x coordinate, y, z, something like that, okay? So when they ask you for the direction cosine, so because you see that these are three-dimensional, three components, that means you have three angles, okay? You have three cosine. That means you have cosine alpha, cosine beta, cosine gamma, right? But first of all, you need to find magnitude first, because you need the magnitude. You need the magnitude for v in the formula. So you got to find the magnitude first. So minus 3 squared plus 2 squared plus 1 squared. So that is your square root of 14. Okay? Alright, so then only now, start with cosine alpha first. So alpha is for the first component, which is minus 3 over square root of 14. Or another word, maybe I'll write step by step. Maybe I can write v1 over magnitude of v. So that means minus 3 over square root of 14. that is cosine alpha. And then cosine beta is for V2 over magnitude of V. That means second component is 2 over square root of 14. Okay, and then the last one is cosine gamma, which is V3 over magnitude of V, which is then 1 over square root of 14. Okay, that's all for direction cosine. Okay, maybe this is I think this is the last question for today. Okay, this time asking you find the direction angles and direction cosine. Actually, enough. Okay, actually cosine must comes first, then only angles. Okay, because you write the cosine first, then only you find angle. Okay, so find the direction cosine and direction angles of a given vector u. So vector u, first of all, find its magnitude, which is 3 squared plus minus 5 squared plus 4 squared. Okay, so you have your 9 plus 25, all right, and then plus 16, so you have your square root of 50. Okay, if I make a mistake, you let me know. Okay, then, okay, one by one again, cosine alpha, okay, 3 over square root 50. All right, but what you want is actually is alpha, which is then cosine inverse of 3 over square root 50. Okay, maybe you can just use calculator. Okay, this is where I should get actually a acute angle because this is cosine inverse of positive. Cosine inverse bracket 3 divided by square root 50 bracket. Okay, so I think you can check with me also. You can use your calculator whether you get. Okay, I just round to the nearest degree. So 65 degrees for alpha, and then for cosine beta is minus 5 over square root of 50. So then beta equals to cosine inverse of minus, okay, because of now is negative. Remember just now earlier when you observe the angle, if it's a negative, that means it must be obtuse angle. Obtuse angle means more than 90 degrees. Again, try using calculator. You check with me also whether you got the same thing. Cosine inverse bracket minus 5 over square root 50 bracket. Okay, round to the nearest degree. You check whether you got the same degree or not. 135 degrees. And then the last one, cosine gamma, 4, okay, positive. 4 over square root 50. So this is cosine gamma. So therefore, gamma is cosine inverse 4 over square root of 50. Again, this is going to be acute angle because it's positive. Okay, so roughly this is nearest degree 56 degrees. You got the same thing? Same angle with me? Everyone?
Yes, madam. Yes.
Okay. All right. So again, this statement like cosine alpha, this is what we call direction cosine. And then finding the angle, this is what we call direction angle. Okay, so when we talk about in three-dimensional space, we will have 3 direction cosines with 3 direction angles. But if it is in 2 space, all right, it will be 2 direction cosine with 2 direction angles. Okay, any question? I think for today I'll stop here because then we have another one more, which is cross product. That will be the last, okay, the last topic. Okay, this one we can actually continue next week. Okay, so we can finish everything by next week, inshallah. So next week will be our last week, our last week of instruction. Okay. Any question for today's lesson? Can you all understood? Can you all understand? Is it understood? Does everyone understand?
Yes, madam.
Yes, madam.
Okay. All right. Any question? All right. Okay. So again, I would like to remind you regarding the tutorial for this Thursday. All right. So as agreed last week, everybody will join in morning session on Thursday. So afternoon session also you will be joining us. All right, for tutorial at 8 o'clock. Okay, on Thursday. And then please catch up with all the questions, especially the complex number, the chapter exercises. Maybe we can just select a few questions to discuss. All right, and then if you have the time, okay, you can just straight away have a look at your tutorial question or exercises, all right, in vectors, in vectors topic, especially the exercises in between sections. All right. Okay, actually, for textbook also there's also certain typos, typo error, and then some maybe it's a typo. It's not, maybe it's not a mistake. It's a typo. But I think maybe I will highlight the typos maybe during tutorial, especially when it comes to unit vector. I just realized actually when I look at the book that day. Okay, under the unit vector, I think there's a couple of typos there. So I will highlight that during tutorial. Okay, if there's no question, then perhaps we can end the session now. Okay, anybody got any questions? Okay. All right, so if not, then perhaps we can end the session. All right, and thank you very much for listening. Thank you very much for your attention. Stay home, stay safe, everyone. So PKP, all right, the MCO starts tonight actually. So all of us also will be like working from home. In fact, we are now working from home already for the past 2 days actually. Okay, due to our colleague actually he got COVID actually, positive COVID. So then our campus technology actually closed down. Okay, so we are all now working from home. Okay, so please, everyone, please stay safe, stay healthy. You are actually approaching to your final semester. I mean, final week of the semester. So final exam is approaching. Okay, so it is actually it's important that you stay healthy, okay, and safe. All right, so I will meet you again, okay, on Thursday. If there's no question from you all, okay, all right. Okay, you're welcome. So I'll see you on. We'll meet again. Okay, we'll meet again on Thursday. Okay, thank you.
Thank you, madam.
All right.
Thank you, madam.
Madam.
Thank you, madam. Take care, madam. Take care.
Okay, welcome.
Madam, Assalamualaikum.
Thank you, madam.
Thank you, madam.